So it's another look at solving simultaneous equations, and you end up, as we saw last time, with unique and non-unique solutions if you're not careful. So it's just trying to get our head around those things in this lesson. So a little starter first of all, and the matrix is this. Find the inverse. Now notice it gives us numbers, so just type it in. There's only one mark, so they can't be wanting you to do it properly. So type that into your calculator, get the answer, and then use it to solve this. And this has got an A in it, so you might have a little bit of work to do. So see what you can do. Okay, so I've typed it in. I've got my answer, so hopefully yours isn't the same. I get 1, 1, 1, 2, 1, minus 1, and minus 1, 0, 3. That's my inverse matrix. And notice now it says solve this simultaneous equation. So effectively, if I just rub this out, we've got that times by x, y, z. I'm just writing this as a matrix equation. And it says it's equal to 12a minus 6 and 7. So what it wants us to do is really move that onto the other side. And it's on the left, so it will go on the left. So to find this now, my x, y, z, once I've moved it over, I'm just being lazy here as you can tell, my inverse matrix of this was this. So that will go into that part there, and I will times it then by the 12a, the minus 6 and the 7 when I'm trying to solve this equation. So I have in there, I've got 12a minus 6 plus 7, I think plus 1. I've got 24a minus 6 minus 7, I think minus 13, and I've got minus 12a, nothing, plus 21. So I suppose I end up here with x equals 12a plus 1. The great thing about doing the calculator, you don't have to worry about the determinant because it's worked it out already for me. Y is 24a minus 13, and the fact I'm really willing to do this tells you just do it. Get the final mark. And I'm going to tidy this up, 21 minus 12a. So that's what I think the answers are. I don't think I've got the answers on it, so hopefully that's it. Unique and non-unique solutions. We saw this last time with 2 by 2 matrices. You either get a unique solution or you get no solutions, and we describe them very often as non-unique. We also saw that you get 3 by 3 matrices, and they represent planes which cross or don't cross. And so here you can see they're all crossing at that one point. But now they're not crossing at all. These are parallel planes. These are 2 parallel planes being intersected, but they kind of intersect in you can't quite see that, but you get intersecting in 2 lines. That basically means there's no unique solutions here. Here again, almost like a triangle. I think the one we saw, we could almost see down it. I think that's like the one we saw in the last video. And therefore, because you can see straight down it, there's nowhere that they all cross. Now this one is a bit weird. This one, there are solutions. They all seem to cross on this straight line. But there's not one unique place where they cross. But here there are solutions. They do exist, but they're non-unique. And of course, for all of these, the determinant is 0. And the only time you get the determinant not equal to 0 is when you get a unique solution, like our little dot there. So I've got a little question for us to try to do. It's very similar actually to the last one, but notice I've got 7 marks for this first part. So that implies we've got to do a bit of work. The matrix D is given by this. And it says where A is not equal to 2. Now my guess is they're saying that because when I do the determinant will mean that if A is 2, I get a problem. So that's probably why they're doing it. Let's do the determinant first of all. Let's work out A1. And that is equal to 1, 2 minus 1, 1. Which is 1 plus 2, which is 3. I've got B1, which is a negative version of 3, 2, 0, 1, which is minus 3 minus 0, which I think is minus 3. My last one is C1, which presumably then is 3, 1, 0, minus 1. And that is equal to minus 3 minus nothing. So that's it. So the determinant will be a times by 3 plus 2 times by the negative 3 plus 0 times by negative 3 as well. So let's see, that gives me 3a minus 6. Oh yeah, notice if a is equal to 2 then, that would equal 0. So I was right to assume that if a is 2, that would give me a 0 determinant. So in this particular case, they're saying really, find me a solution. So hence or rather, solve these equations. And the reason I can solve it, the reason why there will be one single solution is because we have got a not equal to 2, therefore the determinant will not equal 0. So it's important that to just get your head around that. So what's it want me to do here? Well, this is back to, I've got to now find, I'll find A2. That's a negative. Notice there's 11 marks for this question, so it's fair enough that I'm having to do some work. It's 2, 0, minus 1, 1. I do like noughts and ones. B2 is positive, so that will just be A0, 0, 1. And C2 will be a negative version again. And hopefully you've sussed this all now, and hopefully I have as well. A2, 0, minus 1. So I'll work all those out, and then I'll work out the 3's. So that's minus, so that's 2 minus nothing. So I reckon that's minus 2. We've got this being, that's just A, minus nothing. And this being minus A, minus nothing. This is why we like these so much when they are when they have these noughts and ones, because everything does simplify a bit. Over here I'll do A3, B3, and C3. A3 is a positive, so it is 2, 0, 1, 2, which is 4 minus nothing. This is a negative, and I've got A0 and 3, 2. So what does that give me? That gives me 2a minus nothing. Okay, and then C3. What does C3 give me? That gives me A2 and 3, 1, which gives me A minus 6. So effectively then, I can put all these together. Now, the matrix was called D for some reason, so I can write D, and the matrix of cofactors, DC. I'm just going to write that out. What have I got? I've got this top row, which will be 3 minus 3 minus 3. Second row will be minus 2AA. And my third row is 4, 2A, and A minus 6. Now, of course, what we're going to use that for is normally we'd have this here as a matrix, and I would have written right at the start. Let's do it now. A2 0 3 1 2 0 minus 1 1. I would have written x y z, and I'm saying that is equal to the 3 4 1. And of course, what I need to do is move that over. Oh, I just realised I pressed the answer by the next line by mistake. That is the matrix I should have got. Did I get that? Well, allowing for the matrix, the divided by the determinant, I think I will end up with that. So I don't know how I managed to do that, but I've managed to get the answer for the determinant up. I shall do that in a bit. But what I'm doing then is I'm going to move that over there, and it's going to become x, y, z. And it's going to be the inverse of this, and that's what I'll get. So there'll be 1 over the determinant, and I've already seen the determinant is 3a minus 6. It will be times by the transposed version of that, and that's what's going to give me the inverse. So just looking at that, the 3 minus 3 minus 3 will go downwards. Then it will go minus 2aa downwards, and then finally 4, 2a. I was at minus 2a. According to that, it's minus 2a. Do I agree with that? Oh, yeah, because it's that minus there. Oh, good job, I spotted that. Minus 2a and a minus 6. So on that basis then, that then is the inverse matrix, and we times that by 3, 4, 1, and we'll get our answer. So I'm not going to touch that 1 over 3a minus 6. I'm just going to now do my multiplication. It's 9 minus 8, that's 1, plus 4, that's 5. So I reckon the first number's 5. I might have to just do a bit of working out on some of these harder ones. Minus 9, let's just write it here, minus 9, plus 4a, and I'll do the next one, minus 2a. So I reckon that's 2a minus 9. And the last one is minus 9, plus 4a, plus an a minus 6. I reckon that's 5a, minus 15. So that's what I think the answer is. Now obviously you would have to write x equals, and it's going to end up being 5 over 3a minus 6. And y will be this over 3a minus 6. What have I got? Oh, I just wrote it like that. I couldn't be bothered. 2a minus 1, and I've got the right answer anyway. But I would probably want to write it x equals, y equals, z equals, just for completeness. So 5 over 3a minus 6, etc. But I'll leave you to play with that. We are, for the first time, actually now going to have a chance to look at the exercise. So this is exercise 3a. It's on page 68, and I think we'll make a lot of sense on that because we've spent so much time on it now. So best of luck.